I look up at the night sky, a vast canvas of darkness dotted with twinkling stars. It's a breathtaking sight, a glimpse into the infinite expanse of the cosmos. But what we see, the brilliant stars and luminous galaxies, is only a small fraction of what's actually out there. Hidden from our view, composing the majority of the universe, are two mysterious entities, dark matter and dark energy. They are the invisible forces shaping the cosmos, the silent conductors of the cosmic symphony. For centuries, we believed that the universe was composed primarily of the matter we could see and touch. We studied the stars, mapped the galaxies, and believed we were close to unraveling the secrets of the cosmos. Yet, the more we observed, the more we realized that something was amiss. Our equations didn't add up. There was a discrepancy between the gravitational effects we observed and the amount of visible matter present. This discrepancy pointed to the existence of something more, something hidden from our direct observation, something massive, exerting a gravitational pull on the visible matter, yet invisible to our telescopes. This mysterious substance, this cosmic glue, came to be known as dark matter. And if the existence of dark matter wasn't perplexing enough, further observations revealed another astonishing fact. The universe wasn't just expanding, it was doing so at an accelerating rate. This discovery shook the foundations of cosmology. What force could be driving this accelerated expansion? The answer, it seemed, lay in another enigmatic entity, even more pervasive than dark matter, dark energy. Imagine a cosmic recipe, a list of ingredients that make up everything we see and everything we don't see in the universe. You might expect this recipe to be dominated by the familiar stuff, the atoms that make up stars, planets, and even us. Surprisingly, these familiar ingredients, the stuff we consider normal matter, make up a tiny fraction of the cosmic recipe, a mere 5%. The lion's share of the universe, a whopping 27%, is made up of dark matter. This invisible substance doesn't emit, absorb, or reflect light, making it impossible to detect directly. Its presence is inferred through its gravitational effects on the visible matter around it, like an invisible hand shaping the cosmic landscape. The remaining 68% of the universe is a truly enigmatic entity, dark energy. Unlike dark matter, which clumps together under the influence of gravity, dark energy seems to be evenly distributed throughout space. It acts as a sort of anti-gravity, pushing everything apart and driving the accelerating expansion of the universe. Think of it like this. Imagine raisins scattered throughout a loaf of bread dough. As the dough rises, the raisins move apart from each other. In this analogy, the raisins represent galaxies, and the expanding dough represents the fabric of space-time itself, stretched by the mysterious force of dark energy. If we could see dark matter, it would be like looking at a cosmic web, a vast, intricate network of filaments and halos spanning the universe. Galaxies, like sparkling jewels, would be strung along these filaments, held together by the invisible grip of dark matter. The existence of dark matter was first proposed in the 1930s by Fritz Zwicky, a Swiss astronomer studying the Coma Cluster, a massive collection of galaxies. Zwicky noticed that the galaxies within the cluster were moving much faster than they should have been based on the visible matter alone. The only explanation, he concluded, was that there must be some unseen matter providing the extra gravitational pull to keep the cluster from flying apart. Further evidence for dark matter came from observations of the rotation of spiral galaxies. Astronomers expected that the stars in these galaxies would orbit the galactic center in a similar way that planets orbit the sun, faster closer to the center, slower farther out. However, they found that the stars in the outer regions of spiral galaxies were moving much faster than predicted, as if they were being influenced by the gravity of an invisible halo of matter. This invisible halo, astronomers realized, was dark matter, acting as the scaffolding upon which galaxies are built. It provides the gravitational glue that holds galaxies together, preventing them from spinning apart. In the late 1990s, two independent teams of astronomers made a startling discovery. They were studying distant supernovae, exploding stars that serve as standard candles, allowing astronomers to measure cosmic distances. What they found was unexpected and profound. The expansion of the universe wasn't slowing down as they had anticipated, it was speeding up. This discovery, which earned the researchers the 2011 Nobel Prize in Physics, sent shockwaves through the scientific community. It meant that some unknown force was counteracting the pull of gravity, pushing everything in the universe farther and farther apart at an ever-increasing rate. This mysterious force, this cosmic accelerant, came to be known as dark energy. The nature of dark energy remains one of the biggest unsolved mysteries in modern physics. Some physicists believe it's a property of space itself, a sort of cosmological constant that Einstein first proposed and then later discarded. Others speculate that it could be a new type of energy field, a quintessence that permeates all of space. Whatever its true nature, dark energy has profound implications for the fate of the universe. If its influence continues to dominate, the universe will continue to expand forever. Galaxies will be pushed farther and farther apart, and the universe will become a cold, dark, and lonely place.